Hi, everybody, and welcome back to the EBI Seminar Series. This episode, we're going to be joined by Professor Michele Stanley, who is the Associate Director for Science, Enterprise, and Innovation at the Scottish Association for Marine Science. Professor Stanley is going to be joining us to discuss breeding programs for seaweed and the science behind it. Thank you for watching and enjoy. Hi, Michele. How are you doing today?
I'm not doing too badly, Logan.
That's good. That's good to hear. Okay, well, we thank you for being here. We're going to be talking about seaweed breeding programs today. So, to start us off, can you explain the importance behind seaweed breeding programs?
So the importance behind it is to start building resilience into seaweeds that we're cultivating. But seaweed breeding programs, if we have a look at China, they've actually been breeding since the late 1960s. And that's why they dominate currently production in one particular species, and that's Saccharina japonica. And they produce about 10 million wet tons annually of that one species of seaweed. But that's been selected for increased biomass. So getting more biomass than you would have just growing, what we would describe as a wild type seaweed.
Okay, and then can you explain the science behind breeding programs in a very general way?
So it's like plants, although seaweeds technically aren't plants. You've got males and females. So literally, you're just crossing the female from one seaweed with the male from another. And that's what it is. So it's no different to what we see in plant breeding. And even, if we're looking at fungi we use for industrial purposes, it's the same thing that happens there as well.
Okay, that's good to know. And then can you explain to us what the challenges are in scaling seaweed breeding programs since they seem to be important? So how can we develop them more?
So we don't actually understand the populations that much. So you can have a stand of seaweeds, and they're not all the same, but we're not quite clear about how diverse they are. So one of the challenges is, how many crosses do you have to do between males and females, and what you're actually screening for as well. So it's being very clear about what you want at the end. Is it more biomass? And to do that, you're not necessarily going to see a result for a year or in 9 months to a year, because you need to do the cross, you need to let it develop, and then you need to put it out at sea and see how it does in the environment, where you're going to grow it.
Okay, and what progress has been made in breeding seaweeds for higher yields or more resilient varieties?
As I said, the Chinese have done it for higher yields, and they've even crossbred different species together. But one thing that's missing currently is building in resilience in terms of things like climate change. So we do know the oceans are getting warmer, and for species that we're interested in Europe and in North America, they're what we would describe as cold water temperate species. And we're getting a 1 degree, a 1 degree increase in seawater temperature means that they could die back. And we're already seeing that in the UK. So we've got species moving sort of northwards. So if we want to build a resilience and we want to keep on growing the same seaweeds, one thing we probably should be looking at is things like thermotolerance, so making them more resilient to temperature increases.
How prevalent would you say seaweed breeding programs are globally? I know you've talked a little bit about China, you've talked a little bit about the UK.
So another good place is Chile, and they've been working on giant kelp, so macrocystis, which you get up in California. So they've been doing breeding programs in Chile. And then there's interest in breeding programs and different strains of seaweeds, different strains of macrocystis to grow along the Namibian coast in Africa.
Okay, interesting. How do you think seaweed compares to other feedstocks in terms of sustainability and efficiency? I know you've talked about this briefly, but could you expand on that a little bit?
So at the moment, it comes down to really what you want to use the seaweed for. And to make the sustainability shift, it's actually making the most of the biomass. So it's not just going for one product. So it's going for, if you can get more than one product out, that starts to shift the economics because it's expensive at the moment to farm. Countries like China, so what we would describe as low to middle income countries, where you get a lot of seaweed cultivation happening. The reason why it happens there and it's cheap to do is because labor costs are cheap. So as you see it developing again, sort of within Europe and within North America, it's mechanizing the system. So it's not just breeding, but it's actually having a look at what you're doing as a whole. So how you mechanize, how you harvest, because in other countries where seaweed cultivation is already prevalent, it's because of labor. So that's what we're competing with. So it's breeding for what you're interested in. Now, if that's more biomass, great. But then it's also being able to, instead of using manual labor to actually pull up, tons of seaweed, it's developing those machines that can operate in the marine environment and cut the seaweed and harvest it for you.
So for other agricultural feedstocks and such, I assume that they already have the mechanized, the more mechanical labor. Is it because we don't have the mechanical labor and it's more of a dangerous process that it's more expensive for seaweed?
We don't have, I mean, if you have a look at agriculture, we've been practicing that for 4,000 years. So it's been going on for a long time. Seaweed cultivation, really, there's some records of it, sort of 1700s. We have a look at Northern Ireland, Ireland, some records of basic cultivation going on in the 1800s, the 1800s, and it's just we're playing catch up. So I said about China really started selective breeding late 1960s, and we have a look at what we've been doing with wheat, potatoes, all of that's well established. So we're just playing catch up with all of that.
I see. And how do you foresee seaweed being used more widely in industrial applications in the future?
So it's an interesting one. We have a company that's in one of the buildings close to us, Oceanum, and they're actually taking a biorefinery approach to seaweed. So they're making sure they're producing more than one product, and that's everything from interesting polymers, seaweed leather, and also paint as well with the pigments. And that's we have a habit as humans just wanting one product from a plant, from a crop. And we're having to now look at, if we want it to be more sustainable, and we don't want any waste, it's actually taking that biorefinery approach, or what you would look at in terms of the bioeconomy as well.
Okay, very interesting and super exciting. So that does it for all of our questions, but thank you so much for joining us. This was a super informative conversation, and yeah, we thank you again for having this conversation with us.
Thank you.
Thank you for checking out the EBI seminar series on the bioeconomy and the seaweed supply chain. If you've enjoyed this video, please feel free to like and subscribe to our channel for more content on the macroalgae bioeconomy. Be sure to follow along for future installments or check out our previous series and explore our social media, which are all linked in the description below. Thank you for watching and see you next time.